a pretty significant project and a new technology and a good technology transfer for India. And that's that picture right here. You can see the floor beams, all of those floor beams, hybrid composite titanium will be made right here in India. Oh, why do I have this? I guess I'm not supposed to show you this. No, I'm just kidding. Okay. Okay, so now let's get into some of the details real quick. And in terms of design, the primary structure is composite. Why is it that important? Other than few things I will talk about, the benefits to the passengers, the first heavy maintenance visit for this aircraft is going to be 12 years after you introduce in the service. Typically, you had 7 years for our earlier aircraft or our competition's aircraft. Now you're going to have a long maintenance interval, and it's going to do new design possibilities. The new aerodynamic efficiency, the wing is 7% more efficient than the 777 wing, which is our last best airplane we built, and is going to cruise at Mach 0.85, which is pretty close to the 747-400, which is one of the fastest airplanes in the world, and with low fuel consumption. That is the key. Those go hand in hand. We have a lot of innovative systems. I'm going to show you some. And then we have GE and Rolls doing the latest engine technology, which is going to help not only with the fuel burn, but with the emissions, again, the green thing, and also with the small noise footprint, because as you heard earlier from Mr. Baveja's pitch, people don't like noise. If they are in that cone of noise, they are not happy. When you see this airplane footprint, which I'm going to show you, it's barely on the airport itself. So when you are in an airport, it's barely going to really affect the people who live in the boundaries of the airport. So how did we get to this better fuel efficiency, better operating cost? Well, there are four basic things that contributed. One is aerodynamics, as I said, a new wing design. I told you about engines, that is going to contribute. And what this pie is showing, as we are looking at approximately 15 to 20% improvement in terms of fuel efficiency, in terms of operating cost compared to today's aircraft. And in those particular improvement, the pie that is shown roughly is the contribution of each of those components. So equally, aerodynamics, engines, systems, and to a lesser extent materials, the composite materials, is what is going to contribute. And what you see around the circle here is what is the benefit of doing all that. And really, the one that I want to point out, the higher residual value, it's important today because while we are all in a scientific community here, the banks are very leery about giving money to the airlines or anybody for that matter for anything. And if they see an airplane that has better residual value, has lower risk, they're willing to finance it, and that's an important aspect when you choose this airplane. Now here is the little bit of detail on where we are using composites, okay? You can see the blue, the dark blue is the carbon laminate, the light blue is the carbon sandwich, and then we have aluminum, titanium, and all these different things. This has resulted in the light part of the L that Mr. Baveja was talking about. This airplane is really lighter and much stronger because of the composite materials, and it has reduced maintenance costs because you have improved fatigue. You know, composites are not like aluminum, they're man-made materials, so you don't have to worry about that. And then you have simplified inspections, and we have multiple repair techniques that you can do on composites. Now I'm going to go through 3 or 4 charts just to show you some of the technologies. For the lack of time, I won't get into too much detail on this, but you can see the raked wingtips will enhance the wing efficiency. We've already been using it. We have it on our 47-8 also. So it's a known technology that we have put. We have done variable camber for wing optimization during cruise, and we have done the groupable spoilers to again increase the wing efficiency. So this is how we build a high aspect ratio, state-of-the-art wing, which is giving us that 8% improvement compared to our own 777 wing that has been very successful. In addition to that, we did on the nacelles of the engines, we have done laminar flow, which will reduce the fuel consumption. We have done multifunction ailerons to optimize the wing for takeoff and cruise. And then we have done the simple pivot trailing edge flap to reduce the complexity of the wing, because again, if we can build it cheaper, we can sell it cheaper, and thereby you can get a better operating cost. That was a part of the lower acquisition cost that you saw in the earlier pitch. And then we have separation systems. We have chevrons on the engines, which is really helping to reduce the shock cell noise, and also it is helping us with the weight of the engine. Thereby, you have more payload in terms of passenger or cargo rather than having the OEW or operating empty weight of the aircraft. And what we did in this airplane was all open systems architecture. We didn't want to create this proprietary stuff that only somebody can build avionics or internal software for it. It's a common industry software design standard, so many people can do design for it. The applications, sensors, and effectors are all connected via a common, simple data network. Again, simple is good. And what I'm going to show you here is a whole bunch of new technologies that we have added on this aircraft. Why that is crucial is now we have a lot of IT stuff, and as you heard earlier, a lot of IT gets done in India itself. But the E-enabled airplane, as we call it, we can collect a lot of data. As this airplane will be flying, for example, you will be collecting data on the engine performance, on the airplane performance. If something is going wrong in the engine, the station where it's landing next will know in advance what went wrong, what needs to be done, what parts need to be replaced. They can go in the maintenance manual, which is all digital, and find out what kind of procedure that needs to be done so you can replace that part. And all those things are really important because time is money, and you know how you hate if the flight is delayed even by 15 minutes. So if this airplane comes and it is supposed to go on from point A next to the next station, if you know all this in advance, you probably can do a lot better. The whole IFE, which is the in-flight entertainment system, is one of the most complex things in today's aircraft. And we're trying to make a simpler system for this aircraft because when we fly these long hours like Mumbai, New York for 15, 16 hours, we want to watch many movies. We want to do movies on demand. We are not happy with just watching what is being shown on the screen. And so if you fly Air India or Jet Airways 777, you will find they have large TVs like 22-inch TVs in first class, 16-inch TVs in business class, and even in economy, every seat has a 9, 10-inch TV with a choice of multitude of movies and songs and all those things. But all that stuff also brings a lot of challenges, and we're going to fix all those because I know for sure when we introduced the 777s in Air India, initially they had a lot of issues with the in-flight entertainment, which is again a vendor's supplied software, but nonetheless it's a Boeing airplane and we get involved with it quite a bit. One more thing we did is we are trying to use as less pneumatic power in this aircraft. So we have no bleed air from the engines being used. By not having that, you don't